Hi, statistics students. We're going to start chapter 4 today, discrete probability distributions. On page 193 in your textbook, you're going to find an introduction to what we're going to be studying in chapter 4. So basically, you're going to be able to find probabilities of events that are called discrete events. Discrete's going to mean that you can count the outcomes. And so if we know about discrete probability distributions, we can make inferences, and that's where we're going to go with this. So we start off with your outline for the chapter. It's only 3 sections long. And the first one is Lesson 4.1, Probability Distributions. In this video, I'm only going to take you about halfway through the notes. And what I want you to do is things that I highlight need to be in your notebook. So take good notes. There's going to be times where you're going to be snapping pictures of your notes and submitting those kind of as an exit ticket for participating in the class. So take good notes, put them in your stats notebook, and we'll keep going. So as I highlight things, that's what you need to put in your notebook. All right. We have some objectives we're going to cover. We're going to start talking about a discrete random variable versus continuous. We're going to make a probability distribution and graph it. We're going to determine if a distribution is a probability distribution. We'll find mean, variance, and standard deviation for the probability distribution, and we'll find the expected value of a discrete probability distribution. We're going to get all the way through this much in this first video. So the second video will focus on finding variance, standard deviation, and so forth. All right, we start off with a discussion of random variables. All right, a random variable, it's denoted by X. It's going to be a numerical value associated with each outcome of a probability distribution. It could be the number of sales calls a salesperson makes in a day. It could be the number of hours spent on sales calls in a day. Your random variable is either going to be continuous or discrete. And we start off by talking about discrete. Discrete means it has a countable number of possible outcomes. For example, the sales calls a person makes is discrete. It's countable. He either made 0, 1, 2, 3, 4, or 5 perhaps in a day. So discrete you're going to tie with countable. Continuous random variables, though, they're uncountable. For example, they're going to be represented by something on a number line, like hours spent on calls in a day. You might spend 1 hour exactly, 1.5 hours, 2 1/4, 20 minutes, 10 seconds, etc. So anything that you're going to measure is going to be considered continuous. All right, in the first example, and I want you to copy these examples into your notes, determine whether the random variable X is discrete or not. So go ahead and copy example 1 into your notes. It's the number of stocks in the Dow Jones Industrial Average on a given day. That is going to be discrete because the number of stocks can be counted. All right, the second example here. The random variable X represents the volume of water in a 32-ounce container. Remember that anything you measure is going to be considered continuous. The amount of water can be any volume between 0 and 32 ounces. For example, it might be 1 ounce, 3.5 ounces, 2.6 ounces, etc. Okay, I've added a few extra examples that also need to be put into your notebook. The first one says that X represents the length of time it takes to complete these notes while on house arrest. All right, time is something you're going to measure, so that will be a continuous random variable. And then the second one, X represents the number of times Mrs. Crane has to tell Bryson Morgan to stop talking and start working. Tried to add in a little humor. I do miss you guys and wish I was there in class teaching you instead of you listening to me talk on a video. But in this case, X is going to be discrete. You can count the number of times I've asked you to be quiet. All right. Discrete probability distributions. All right. There's two criteria that you just need to memorize and get down. But first of all, any probability has to be between 0 and 1 in your distribution, and the sum of your probabilities has to be equal to 1. So two criteria have to be there if you're going to have a discrete probability distribution. All right, here are the directions on how to make a discrete probability distribution. I will show you how to do this when we do the examples. I'll talk about what steps they're doing and so forth, and we'll practice one of these together. The first thing you're going to do is make what we call a frequency distribution. Then you're going to find the sum of your frequencies. We're going to find the probability of each outcome, and then we're going to check the criteria. Each probability has to be between 0 and 1, and the sum of them is 1. Okay, so in their example, and you can go ahead and just copy out your table, a psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. So the sum of their frequencies here is going to be 150. All right, they were given a score from 1 to 5. 1 is extremely passive, 5 is extremely aggressive. A score of 3 indicated neither trait. So what they're going to do is construct a probability distribution for the random variable X, and then graph the results in a histogram. Okay. So I'm going to shrink this just so you can see what they're doing. To get their first probability, which is 0.16, so that shows up here in the table, they're just taking the 24 and dividing by the 150. To get P of 2, they're taking, let's change colors here, 33, and they're going to divide by 150, and that's the 0.22 that you see, and so forth. So it's going to look pretty much like a frequency distribution that we had before, except now we're calling it a probability distribution. All right, the next thing you're going to do, once they found all 5 of those probabilities, they're going to double check and make sure that each probability is between 0 and 1. So you want to double check that. And you want to make sure that the sum of your probabilities is equal to 1. So that's super important. And then once you're done there, you're going to make a histogram. And it looks like a frequency histogram, relative frequency histogram, but you're going to be putting probability here on the left and score on the right, or on the bottom. And we'll go from there. So the extra example is this one here. A company tracks the number of sales a new employee makes each day during a 100-day probationary period. All right, the results for one employee are shown below. Construct and graph a probability distribution. So to read this table, you could say that the employee had 19 days where he made 1 sale. He had 9 days where he made 4 sales. He had 2 days where he made 7 sales. So he had a really good day twice, basically. Okay, what we're going to do is we're going to add up our days, and that should be 100. And they told us right here it was 100. All right, I'm going to make my probability distribution vertical. Ooh, that looks really bad. Let me try that again. Okay, that's a little bit better. All right, we're going to have X here, P of X here, 0 through 7. All right, and then 16 over 100, 0.16, 0.19, 0.15, 0.21, 0.09, 0.10, 0.08, 0.02. All right, this is your probability distribution. Now, we want to make sure our criteria are met. So all probabilities are between 0 and 1. We've met that criteria for a probability distribution. And we want to make sure that when we add these up, we do indeed get 1. For the histogram, you guys know how to make histograms, so I'm not going to spend a lot of time here. You will need to scale. I'm going to count by 500ths. These are going to be your probabilities. So this axis would get the heading P of X. This is going to be X. And then you would go ahead and graph your bars. So you're going to have a bar for 0. A bar for 1. Your bars should be all equally of the same width. So a bar for 2. A bar for 3. And so on. So you would continue on until you get all 8 bars on your histogram. All right. I'm going to pause this video right here. In order to upload it on YouTube, I can only have under a 15-minute video. So I'm right at about 13 minutes. So I'm going to pause right here and then start another video and show you how to do the mean. Once we get through those notes, then you'll have enough information to do the first assignment for lesson 4.1. Okay, so again, you should have included this extra example in your notes, and I will pause the video here.